Hi, welcome to Chapter 3 and Video 3.1a, Absolute and Relative Extrema. Okay, so what we have are extreme values, which are either maximums or minimums. These three blue graphs represent the three kinds of maximum points that you could have. Either a horizontal tangent line, i.e. the first derivative is 0, a vertical tangent line, i.e. the first derivative doesn't exist, or a sharp turn, again where the derivative doesn't exist because the derivative from the left does not equal the derivative from the right. But one thing's for sure, if you have a max or a min, your derivative is either 0 or non-existent there. Same thing with minimums. Now, as far as absolute extrema, you'll notice each one of that's the highest point in its little neighborhood, that's the lowest point in its little neighborhood, that's the highest point in its little neighborhood. These are called relative extrema. But this point also happens to be the highest point on the entire graph. That's called the absolute maximum. There is no absolute minimum here because it goes down forever. Another name for relative, by the way, is local. Another name for absolute, by the way, is global. Okay, so in this case, they're going to give you graphs. They're going to say find the value of the derivative if it exists at each indicated extremum. They're going to actually put a big dot and label the point where there is an extremum, and they're going to ask you what the derivative is. So the derivative of this function is by the chain rule negative sign pi over 2x times pi over 2. At 0, sure enough, you get an answer of 0, which it looks like there is a slope of 0. And at 2, you also will get an answer of 0. A critical number, just to look at this graph and just to kind of set the stage for what's coming. When you have a max, your slope is 0, for example, here. But you'll notice also that to have a max, as you move from left to right, your y, your f of x, your function is increasing and then decreasing. But for a min, on the left, the function is decreasing, on the right, it's increasing, and then that repeats itself. We already talked about horizontal tangent line, vertical tangent line, no tangent line. The critical numbers that we'll be talking about are going to have to be in the domain of the function. And you have to understand that if you do have a max or a min, then you are going to have a derivative of 0 or non-existent. But the converse is not necessarily true. Just because the first derivative is 0 or non-existent does not necessarily imply a max or min. Here's an example where your horizontal tangent line does not give a max or a min, and the reason is because the function's increasing on both sides. It's called a point of inflection. That'll come later. Here's one also where there's a vertical tangent line. The first derivative does not exist at that number. However, it's not a max or min because, again, the function increases on both sides. The book's definition of a critical number is let f be defined at c if f prime of c is 0, or if f is not differentiable at c, then c is a critical number of f. I think a better one is to say if c is in the domain of f, which is their version of if f is defined at c. And if f prime is c or doesn't exist, which is the same thing as saying the function is not differentiable, then c is a critical number of f. Now, a critical number is just the x-coordinate of a critical point. A critical point would be the x and the y coordinate. So at a critical point, you could have a relative max, you could have a relative min, or you could have this thing called a point of inflection. In numbers 7 through 10, they give you the graph. It says approximate the critical numbers of the function. So they're asking you to just look at the graph and see if you can think of a place where there's a horizontal tangent line, a vertical tangent line, or no tangent line. And then it's saying, okay, determine whether the function has a relative max, a relative min, an absolute max, an absolute min, or none of these at each critical number. So it looks like there's a horizontal tangent line here at 0. However, it's a point of inflection. It's not any kind of max or min. Numbers 11 through 16, they no longer give you a graph. They just give you a function. They say find the critical numbers. Not the points, just the critical numbers. And you don't have to decide if they're maxes or mins or points of inflection. Your steps are first find the domain of the function. Then find the derivative and ask yourself when is the derivative 0 or non-existent. Number 12 is a polynomial function. Its domain is all real numbers. Here's the derivative. A polynomial will never not exist, but get into the habit of asking yourself that question every time. When does it equal 0? Factor the left side, and you get these 3 critical numbers. And that's the end of video 3.1a.